guys, we are going to learn about balancing equations in this video. This is a balance, by the way, and so I like to think of a balance when I'm balancing equations. And what needs to be balanced is everything on the reactant side balanced with everything on the product side. So let's go ahead and look at a chemical equation here. We've got hydrogen and oxygen. They're diatomic. We learned about that yesterday. And it forms water. So H2 is like 2 purple dots here. O2 is 2 orange dots. You know, it's bigger than the hydrogen. And here we have a water molecule. Well, there's 2 purples on my product side, 2 purples on the reactant side. Great. There's 2 oranges on my reactant side, but only 1 on my product side. Only 1 oxygen is on the product side, and there's 2 here. So this equation is unbalanced. We have more on our reactant side than we have on our product side. So to balance it, you can add coefficients, the numbers in front. You cannot change or add a subscript. It's a little tempting to want to add a 2 down here, but then it wouldn't be water anymore. It would be hydrogen peroxide. So how can we balance this equation by putting coefficients in front? Well, we need another oxygen. So let's put a 2 here. Now we have 2 oxygens. That coefficient distributes through everything. So we now have 2 oxygens, but now we have 4 hydrogens. Over here we only had 2. So to get now our reactant side, the hydrogens to balance, we need a coefficient of a 2 here. Let's check. If we have 2 hydrogens, 2 H2s for a total of 4 hydrogens. Over here, there are 4 hydrogens. When there's no number out front, it's understood to be a 1. You can put a 1 if you want, but you don't have to. And if there's nothing there, it's understood to be a 1. And so now we have 2 oxygens here. This distributes through the entire formula. So now we have 2 oxygens here, 2 and 2. This is now balanced. Most important thing, you balance with coefficients. You do not change the subscripts. Okay, so I think what we need to do is to practice just counting atoms. Now, the idea in balancing equations is, you know, we are obeying the law of conservation of mass. We're obeying that law. It's very important. So all of our atoms on the reactant side have to balance or equal the atoms on the product side. Well, sometimes that can be tricky, just to see how many atoms you have. This is magnesium acetate. And the parentheses is around our polyatomic ion, and then there's a subscript outside of the parentheses. That too is going to distribute to everything in the parentheses, but not to the magnesium. All right, so let's have a look at this. Magnesium, we have 1 in this formula, magnesium acetate. Carbons, all right, there's 2. And then there's this 2 outside that distributes through the entire parentheses. So now we have 4 carbons. We have 3 hydrogens in 1 acetate times 2. We have a total of 6 hydrogens. And then for oxygen, there's 2 times 2, it's 4. Sometimes I tell my students, think of this acetate with the 2 outside as having 2 acetates, and then you just add it all together. 4 carbons, 6 hydrogens, and 4 oxygens. Again, the 2 distributes through the parentheses. What if you put a coefficient out front? So we've got 2 magnesium acetates. Well, that just means that you double everything in this molecule. You have 2 of these. All right, so we need to double everything. So we don't just have 1 magnesium, we have 2. It distributes through the entire formula. We don't have 4 carbons, we have 8. Let's look at that. 2 carbons here, times 2 is 4, times 2 is 8. For hydrogens, we have 6 hydrogens. Oh, times 2, we have 12 hydrogens. And the oxygens, well, we have 4, in one magnesium acetate molecule, but now we have 2 molecules for a total of 8. So you just have to practice making sure you're counting your atoms correctly before you can balance the chemical equation. And these are the most tricky things you're going to encounter. All right, well, let's look at an equation and you decide if it is balanced. All right, we have aluminum sulfate with calcium hydroxide forming aluminum hydroxide and calcium sulfate. My coefficients I put out front in orange, and sometimes just to remind students to put a coefficient into balance, I'll put a line out front like, hey, you need to put a number in there. Don't mess with anything else. All right, well, let's go ahead and have a look here. On this side, I have 2 aluminums. Now, the polyatomic ion in this equation doesn't separate from reactants to products. So I'm going to use sulfate as one complete unit. I have 3 sulfates. I'm not going to break it up into sulfur and oxygen. If the polyatomic ion had changed over here, I would have to do that. All right, I have, let's see, a 3 with the calcium, so 3 calciums. And how many hydroxides? Well, 2 times 3, I have 6 hydroxides. All right, if this equation is balanced, I'll have the same amount on our product side. 2 aluminums, that 2 distributes through the whole thing. I have 6 hydroxides, I have 3 calciums, and I have 3 sulfates. Is this equation balanced? It is. We have the same amount of aluminum, calcium, sulfates, and hydroxides on the reactant side and the product side. It's balanced. Okay, again, this is one of the more trickier ones to balance. Let's try balancing this equation. Nitrogen plus lithium yields lithium nitride. And I have our little blanks out here to put in some coefficients. Well, right now, this side has 2 nitrogens, and this side only has 1. So there's something missing there. Over here, we've got 1 lithium, and we have 3 lithiums over here. We'll pick one thing to balance first. I think I'm going to balance the lithium first. It doesn't matter what you balance first. So if I'm going to balance my lithium, I'm going to need to put a 3 there. So lithium is balanced. How about the nitrogen? It's not balanced. I have 1 here, but 2 over here, so I better put a 2 here to get that balanced. Now that I've balanced my nitrogen, I have 2 nitrogens, I've now unbalanced the lithium. And that's okay. Having an eraser handy is a really good thing in this unit. All right, so how many lithiums do I now have on this side, on my product side? 2 times 3, I have 6 lithium. So it's fine to go back and change this to a 6. All right, so sometimes when you balance one atom, it'll unbalance something you've already balanced, and that's okay. Just go back and fix it. All right, so we've got a coefficient of a 1 and 2 plus 6 lithium yields 2 lithium nitride. How many nitrogens over here? 2. How many lithiums? 6. Over here, that 2 distributes through the whole lithium nitride, so we have 6 lithiums and 2 nitrogens. We have a balanced equation. All right, so let's go ahead and just try 2 more equations to balance. And we're going to be doing a simulation of balancing equations tomorrow in class. We're going to have lots of practice. Wow, this looks a little intimidating. This is butane, what you would find in a lighter. In the presence of oxygen, will make CO2 in water. All right, well, first off, pick one thing that only appears on each side one time. So, like, I don't really want to start with oxygen because it's in 2 places over here. I'm going to start with my carbon. I have 4 carbons here, 1 here. Let's fix that with a coefficient of 4. Okay, now I'm going to go to hydrogen. So over here I have 10, over here I have 2, so I'm going to need a coefficient of 5. All right, now it's time to deal with the oxygen. On this side, we have 8 oxygens in the CO2, and oxygen is found in the water. So we have 5 from the water. We have a total of 13 oxygens. Then when you come back here, it's O2. Well, I like to use fractions, and don't let them scare you. Isn't 13 halves times 2 13? It is. So now this is a balanced equation. You know, I don't really like having a fraction as a coefficient, so let's go ahead and get rid of it by multiplying everything through by 2. So we have 2 butanes. That 13 halves now just becomes a 13. This 4 now becomes an 8, and this 5 now becomes a 10. Okay, let's check to see if this is balanced. We have 8 carbons, 20 hydrogens, 20 hydrogens, 26 oxygens, 16 and 10 is 26. It looks scarier than it really is. Okay, let's do one final one. So you're chunking some good old sodium in some water. You're going to get that little fireball going on because it gets very hot. You're going to be producing hydrogen gas and sodium hydroxide. All right, looking up here, the sodiums look good. Oh, it's the hydrogen that's not looking too good. We have 2 here, and then we've got 3 here. So let's go ahead and put a 2 here so that now we have 4 hydrogens, and we can fix those hydrogens by putting a 2 here. Okay, so we've got 2 hydrogens plus 2 hydrogens is 4, and 4 hydrogens. Let's have a look at our oxygens. 2 oxygens, 2 oxygens. Looking pretty good. Let's look at our sodiums. 2 sodiums, 1 sodium, but that's easy to fix. We'll put a 2 there. There we go. And there's an understood 1 here, but I'll just put it in there for us. There's our balanced equation. Well, we're going to practice this a lot in class, and I hope you have fun with this. Bye.